What's up, guys? Watch this video and never be intimidated by regular expressions ever again. This is Ryan from elevatecyber. As you see, I made these notes way back in 2017 when I was first diving into this stuff. And let me just say, when you first get into this stuff, it looks very intimidating. It can be pretty daunting, but once you start to really understand these meta characters, these special characters in regular expressions, you'll really see it's not as difficult as you once thought. And we're just going to do exactly that in this video. Just step through one thing at a time, and we're going to very simply explain how all of this works. So, the first meta character we'll dive into is the dot. This is any single character. So literally any character a single time, okay? So one thing to note is that it typically does not match a new line. In awk, which don't worry about awk, that's just like a command line utility, or basically a programming language. It's really that full blown. But awk handles it a little differently. Most likely, you're probably not using awk too often. So typically, it will not match a new line. But other than that, any character will correspond to this dot here, okay? And then this asterisk here, you're probably familiar with this as a wild card. You know, if you're using it in the shell, it handles it a bit different. You know, in the shell, it's probably what you're typically thinking of when you see this. A wild card that matches anything, right? You can do ls and then type some letters and then do a star. Let me show you. Pretend we're in a bash prompt here, right? We're in shell, just a shell prompt. All right. One thing we could do was, say we are in, I don't know, Etsy right now, right? We're in the Etsy directory, and we wanna do an ls, right? We can do ls for for the Etsy password file. We could do it like this, and it'll actually show us the Etsy password file, right? So here we use an asterisk, and it just meant anything, right? But in regular expressions, it actually has a different meaning. So in regular expressions, it's actually just a modifier of whatever precedes it, whatever character comes before it, okay? Typically, this will be a single character, but not always. So, for example, if we want to do the equivalent of what we just did a second ago, what we would do is dot asterisk. Because remember, the dot is any single character, and the asterisk is 0 or more occurrences of any single character. So effectively, we just said anything. This is effectively just a catch-all wildcard. So, I mean, it doesn't have to be used with the period, obviously. You could use it with any character, right? It could be like the letter T, for example. So now what this means as a regular expression is to look for any 0 or more occurrences of the character T. Notice I didn't say 1 or more, I said 0 or more. That's how this asterisk wildcard works as a regular expression, and also how it differs than you might be used to it and how the shell would deal with it. Now, the next meta character that we'll go over here is these brackets here. All right? Matches any one of the class characters enclosed between the brackets. So here I just have ... as a placeholder, but really you would have a class of characters between the two. And you may have seen it used before, actually, like so. You might see maybe something like this. And this is a class of characters that are basically saying any lowercase character, right? Because A through Z, that's your entire alphabet, lowercase, right? Maybe you even see capital letters, any uppercase character. Basically whatever you have, and you can even have like other stuff enclosed in the brackets as well to include those characters. But that's how these brackets work as a meta character, okay? And when I say meta character, I mean it just has a special meaning when used in the context of regular expressions, right? And here's another one. This is called a circumflex. If you have this caret symbol here, if it's the first character inside the brackets, it means a reverse match to all the characters. That means look for everything except what's in here, right? So for example, let's illustrate that. So we can have, if we lead with the caret symbol, which is this, okay, and we say A through Z, that means return everything that is not a lowercase character, right? And I kind of went over this one already, but the hyphen is used to indicate a range of characters, right? So just like a second ago, how I had, A through Z, I can also have like 1 through 9, different stuff like that, right? Any kind of range of characters. And, the closed bracket is the first character, and the class is a member of the class. So all of the meta characters lose their meaning when specified as members of a class. This is a good thing to take note of there. So as a regular expression, though, like outside of the brackets, this caret has a meaning of its own. And the meaning that it has is actually the beginning of the line, right? You might have seen me do this before in some of the other episodes that I've created over time. But this is a meta character. It means beginning of line. And then similarly, this $, that means end of line. Okay? So pretty simple there. So I use that a lot with said. That's where I, in a practical sense, use this a lot. Say, oh man, let's see. Let me think of an example here. Say we have a line like this is a line of text, okay? And this is our sentence. And we just want it to return the word this, right? We can have an expression, a regular expression that says start at the beginning of line, match, anything. Like, ideally we would have we'd have some other sentences too, like some other lines of text, but we just want to return, this is, I guess, right? So we can have this, and then anything, and then all the way up to S, right? So now it will return just the word this in this case, right? I don't know, maybe that wasn't such a good example. I was trying to think of how to explain it, but basically what you need to know is this is beginning of line, or you can say, hey, I want only the lines that end in DF. See, look, DF right here, right? This is probably a better example. DF, okay? So what I can look for, because I have DF here, I don't want to return that. I want to return DF at the end of this line, let's say, right? So what the regular expression I could have is DF $ for end of line. So I'm looking for anything that are the DFs right at the end of the lines. I don't want to return like this DF or this DF, right? That's a use case there. So that's basically what that is. Hopefully I didn't lose you too much in that. Another cool thing you can do with regular expressions is you can get very granular and actually match a range of occurrences of a single character. So there's two components to this, basically. N is will match exactly n occurrences, and then if you can match at least that many occurrences as well if you have the little comma right here, and you can also do a certain range, or will match any number of occurrences between n and m, right? And so one thing that comes to mind here with this, a use case for it, is say you want to look for phone numbers. Well, phone numbers typically have a particular format to them, right? Like you have 3 numbers for the area code, and then another 3 numbers, and then 4 numbers. Now, I mean, this is assuming you're talking about American phone numbers. This is the general format that we follow here. So what you can do is actually use regular expressions to identify phone numbers in a block of text, right? So remember, this is applying to the character that came before it, right? So you want to look for a number, right? It needs to be a number. So any number 1 through 9, right? There'll be 3 occurrences of that. In this case, we know exactly how many occurrences of it there'll be. There'll be 3. So you can do this, right? So that'll look for 3 occurrences, right? N being the number 3 here. And then we're going to look for this character, this dash, right? Now, in this case, remember, by itself, the hyphen is a meta character used to indicate a range of characters. So if we want to specify, and this goes for any of these meta characters, like, because that brings in one problem, right? Like, okay, this dot means any single character. This $ means end of line. Well, what if I'm actually looking for a $, or for a period, or for an asterisk, or a caret? What if I don't want them to be interpreted as this stuff? I'm looking for that actual string literal, as it would be called. Well, you just need to precede it with a \. That's known as the escape character, which is actually a meta character that means to whatever comes after it, interpret it as a string literal as opposed to a meta character. So if I want to identify this dash here, I just put this \. in front of it. So now instead of interpreting it as a range of characters, it's actually looking for a dash, right? So I can do that. And then, this would be the same thing here, right? And so that's the reason I have these \s here, is because I'm using an escape character here as well. So in this case, it is 3. And also in the case of, and see, look how crazy, how ridiculous this looks. But if you understand what the meta characters mean, you'll see that this is actually very easy to follow, at least in my opinion. And I'll break it down one more time for you guys. I don't want to lose anyone here because this is really not that hard once you guys get to an understanding of what's going on. So this is what it would look like if we're looking for a phone number based off of like this format here. It's going to look for any number. Remember, a class of characters, any number 1 through 9, or I guess really we want to say 0 through 9 because we could have the number 0, right? So 0 through 9, any number, followed by 3 occurrences of any number, right? Followed by a hyphen, and then any number 3 times, 1, 2, 3, followed by another hyphen, and then any number 4 times, right? That will be the format that we're looking for. So this regular expression applied to a block of text would look for phone numbers, basically. So really cool stuff when you actually start to apply it. And yeah, here I say that the \ escapes the special character that follows. Pretty straightforward there. Now here's some extended meta characters, right? Just kind of extending upon what we learned up there. And these are actually really useful things here. You got the + here for 1 or more occurrences of the preceding regex. So if we come back to this asterisk, if you remember, it was 0 or more occurrences. Well, the only difference is the + is 1 or more occurrences. So it's useful in cases where if there's no occurrence of the preceding character, you don't want it to match. You only want to match if there's at least 1 occurrence of that. Then and basically it's a modifier to what came before it, just like the asterisk. So going back to a previous example, it would be between this and this, right? Well, this means 0 or more occurrences of the letter T. This means 1 or more occurrences of the letter T. Now, also you can have the question mark as a modifier, which matches 0 or 1 occurrences of the regular expression. And you can't use this instead, a little special note that I had there. So 0 or 1, so you could have this, right? So it will only match 0 or 1 occurrence of T. So if you have like a bunch of T's, it's not going to match. It's only going to match if you have 1 T or if you have nothing. So there's also the what is this called here? I'm trying to think what this key is called. If you hit the shift key while you're pressing \, it's this kind of straight up character. You might know it as the pipe character when it comes to Linux. It's the same one as used for piping things. But basically it specifies that either the preceding or following regular expression can be matched. So it's basically an or effectively. So you can look for example, we go back here, you can look for the letter T or the letter R, right? You can do something like that. So this looks for, a T or an R. And you can actually group regular expressions together with the parentheses. So that's pretty cool as well. And coming back to the N and M thing, you can also, you can also do it like so. There's basically two different versions of this. And I think one might be a post 6 and the other one is, post 6 egrep, post 6 awk. So it really depends what you're working with. Sometimes they'll expect it in this format, and other times you'll have to use the escape characters here. So it really comes down to what version of regular expressions whatever you're working with uses. So that's one thing to know, right? This is generic regular expressions based off of like pose 6 and stuff like that. But depending on specifically what you're working with, like for example, if you're doing regular expressions in Python using the RE module, well, it might have a certain nuances to the regular expressions, like it might want it in a certain format. But in general, these rules will apply to all regular expressions, right? The fine details you might need to iron out based off of the specific tech that you're using. So this is basically the same thing going on here, though, that we covered earlier. So character classes. So you can actually deal with, upper or lowercase stuff like we were showing earlier, just by encasing them in classes. And that's kind of what we were talking about earlier, right? We basically went over this earlier, and you can actually have multiple classes. So for consecutive characters, right? So what if you had, any lowercase, any uppercase, followed by any of these symbols here? Well, the way you can write it is just like this. You could have like, say, let me give you a fresh example here, right? So you might have something like any lowercase character, and that might be followed up with think about how you write words, right? You could have any uppercase character, because you normally capitalize your words, right? And that could be followed by any lowercase character. So if you do them like this, it looks any uppercase, then after that, any lowercase. So that's one way that you could write that as well. Trying to think of some examples on the fly here. It's actually quite challenging. But yeah, just keep going through this. And this is a little interesting thing to note here. The hyphen actually loses its special meaning within a class if it is the first or last character. Because like we were seeing earlier, the hyphen, it normally indicates a range of characters. So if you use it like at the beginning or the end, it's smart enough to know that you mean it as a string literal instead of the special meaning. So that's pretty cool. And then you have this post 6 character classes that can be useful sometimes, like this space one here. This is the one I probably use the most to look for any white space. But there are also, and I don't think I have it in here, believe it or not, but there's also some stuff that you can do, like any white space, any this or that, by doing like I believe you can look for any white space character by doing \W, and there's different stuff like that you can look for. There's all these character classes here you can do for alphabetic and space and tab and all this stuff too, which is pretty interesting. But that's just pretty useful stuff there. Pretty interesting. This is a little example that I had of how you can match multiple things just by using character classes. It kind of acts like an OR. It looks for N or an O or a single quote, 0 or more times, and then ending with a T. So yeah, this will be enough to do pretty much anything you want to do with regular expressions. And obviously you can reference more documentation for like if you need anything beyond this, but this is going to allow you to look at regular expressions and not be completely intimidated and be able to follow it and step through it and know what's going on. And especially when you use sed and stuff like that, it'll be a lot easier understanding these meta characters and what they do. So a bit of a lengthy video, I know, but hopefully you guys were able to follow up until this point. If you understand regular expressions, you'll have a huge advantage, honestly. You can quickly look for passwords and stuff like that in files. And you can even use it within Python and automating stuff and parsing through files and doing all kinds of crazy stuff. So yeah, if you want to learn more about how to do all of this, make use of this, watch some of my live hacking videos where I use sed. I'll put a link to them right here. Go and watch some of those videos. I'll link the playlist. I used sed a number of times on there with regular expressions, and you can start seeing it. If you watched it the first time and didn't understand it, knowing what you know now, it should be a lot easier. So go ahead and check out that video, and I will see you there. Thanks for watching.